Hey, so welcome back, and this is another daily LeetCode problem. So today's April 1st, and it's actually a binary search question. So let's take a peek at it. Now this is number 704, but it's actually just the straight up default example for the binary search algorithm. So I'm assuming you know it, but if you don't, it's like a famous algorithm for searching through a list here or an array where you want to find a particular number, and it allows you to do this in log n time complexity, and that's only given such that the array is already sorted. So to sort an array, it's like n log n complexity, but once it's sorted, you can find whatever value you're looking for in log n time. And that's because you're going to be constantly splitting that search space in half. And naturally, log base 2 of n is just a mathematical formula that represents how many times you can divide something by 2 is the result of like log base 2 of n. So naturally, if we're constantly splitting up our search space in half each time and just constantly having it, like having it as in it's hard to say that word, having it, like splitting it in half each time, it's going to be a log base 2 of n time complexity. And so it's also going to be O1 of space, and that's just because we're only going to be using the array that's provided to us. We won't even have to modify it or anything. We're just going to be using no extra space, just constant space. So let's go ahead and write out this algorithm. So what we're going to do is we're going to say, okay, we're going to initially have low and high pointers, and we'll set them from 0 because we want to consider all of the values from index 0 and onwards. And then the high because the second pointer will be pointing to the topmost value that we're considering, which will be 12 in this case. And so that will be the length of our array, -1. And so we're going to say, okay, while these pointers are less than or equal to each other. And so this is saying, okay, we're going to keep looking at the search space. Like first we consider this many nodes, and then say we see that the target's on the left, then we consider these nodes here, and then say we consider these nodes. And it's not until these pointers kind of swap places, where when they kind of overstep each other, that you'll say, okay, it's not in this search space. So if we know that these pointers kind of overlap where the high is now less than the low pointer, then you know that, okay, it's not in this search space, and so we'll just return -1. Otherwise, we're going to keep computing and looking for this target, and so we're going to want to calculate what the middle is so that we're able to keep splitting these two pieces in half. And so we're going to say, okay, the midpoint is just equal to, and this is kind of a templated algorithm for it, is the low plus the high divided by 2. And in Python, you want to round down. And so now what we're going to say is, okay, if this current number at this index is our target, then hey, we found it. And so let's just return this index. Otherwise, there's two cases. We either want to take the search space on the right or the search space on the left. And so we say, okay, otherwise, if our number in the at this particular index is greater than our target, we know that, okay, this number is, say that we got the number 5 in this case, and say that the target that we're looking for is actually 0. So we're looking for 0. This would enter this case where, okay, this value is greater than our target 0, so it must be on the left-hand side of the search space. And so we say, okay, we're going to want to update our high pointer, so the right bound, that say, okay, this is the value that, this is the highest index that we can now consider. And so we want to set it equal to the midpoint -1, because we already know it's not at this index since we passed that case. And then otherwise we know that, okay, if the current value is less than the target, then we know that, okay, we want to search on the right side of this search space. And so we just want to set then our low to be equal to the midpoint plus 1. And so that's because, okay, well, we know that we don't want to consider this since we passed this case. And now that we know that, okay, we want to be searching on the rightmost side, say we just looked at 5 and our target's still 9, then we know we want to look at the right search space and we want to kind of shrink from the low pointer onwards to only consider the values that matter. And so we would consider only 9 and 12. Great, so that was just ran successfully. Let's try submitting. And that's the algorithm. So once again, it's time is n log of n, since it's already sorted. And our space is O of 1 because we are just using the array that's provided to us and we're not using any extra data structures. So yeah, I hope that helped and good luck with the rest of your algorithms. Thanks for watching.